Hi everyone, I did something called the Spaghetti Bridge STEM activity, and the overview of this activity is that students are going to explore the breaking strength of spaghetti bridges using pennies. So the idea is that students are going to make predictions about how much weight a bridge could hold in real life situations. So they're kind of going to compare at the end and predict how much does 100 spaghetti strands hold by the end of this activity. So what I had them do is they're going to do the following. They're going to construct a scatter plot. They write the line of best fit, and then they compare and analyze their results to something called the Desmos application, which is just a fancy application of allowing students to kind of see a visual representation of slope, intercept, and their scatter plot. So they're going to do two methods. One was by hand, and then the second one is using the Desmos application that kind of gives them a better, more accurate representation. So some of the directions here, we used two desks to kind of separate the bridges. They used spaghetti, they used yarn, they used a cup, and pennies, obviously. So here are some of the images. The first one here is the resources that I used. All right, the pasta, the cup with string, the pennies, and the tape. And this is what the level would look like. All right, this is one without pennies. You would dangle the cup with over the or thread it through the spaghetti, and you would drop pennies into each cup. So level 1 looks like with pennies here, and then it would break, and then you would write down your information. Follow the same suit with level 2 here with pennies until it would break. So the idea is the more pieces of pasta you have, the more pennies it can hold in the end, and this is where I kind of stopped here with level 3. But you kind of get the idea. It has a really nice connection with a couple of the different disciplines. So I chose figure 7 or 8.7 where you combine 2 or 3 of the disciplines. And the reason I chose that is because it has a nice cross-curricular idea. So they're using math skills. So they're finding slope-intercept, they're constructing scatter plots, and they're comparing their work between their own work and the Desmos application. They're using technology skills, using the Desmos application, where they can evaluate their prior work and then make adjustments based on the computer's outputs. And then finally, they're using engineering skills to develop and create their own bridges. So they're putting themselves in the shoes of the engineer and kind of testing to see what's the best way to do this. In terms of designing the meaningful STEM lesson and how it connects with students and the teacher, on the left here for table 6.2, there's a lot. All right, students get to answer their own questions and ask them. They get to predict. They get to work in collaborative groups when they design and carry out their own investigations. They get to create their own models, like I said, and they're able to then explain their work through their models. And they're heavily engaged and drawing on their own conclusions. And probably the most important thing that I always view is how does that connect to the real world? So they're putting themselves in the shoes of an engineer to understand how an engineer is, coming up with blueprints to design an actual bridge. On the table for 6.3 on the right here, for the teacher part, the teacher has to kind of think, how does this activity relate to something in the real world? And obviously, like we mentioned, it connects right to an engineer's process to develop these bridges. It's heavily vocab based where it ties directly to prior learning, but it more so helps facilitate their learning throughout the lesson. Questioning techniques are also used here. That's really important to have because it allows them to test their own theories and it kind of guides them through the process. And lastly, as the teacher, I make sure that I'm checking in with each group to see not only their progress, but making sure that they are problem solving together, not just individually in any case. So overall, I thought it was a really good lesson. I really enjoy it. I've used it for the past 2 or 3 years now, and I think it's something that students really enjoy with that hands-on approach. Thanks, guys.